Very well. So, everybody, we're going to talk about complex numbers today. Complex numbers. Okay, complex numbers. What are you talking about? Well, remember that at the beginning of the class, we start talking about numbers in general. We said that, hey, we start working with natural numbers denoted by N. Just bold this letter. And we say that, hey, this is the set of counting numbers starting from 1. So the minimum value is 1. The next number is 2. The next number is 3, 4, and the rest of them. Now, a mathematician says, okay, this set doesn't have 0. How do I add 0? They say, well, let us introduce a new set, whole number set, W, which is a set include 0 and the rest of the numbers, natural numbers, 1, 2, 3, 4, and the rest of them. Remember that back in those days, they didn't have fractions, they didn't have negative numbers. Then throughout the years, they came up with those numbers and those concepts. So they started defining something new. As you can see, here you do not see any negative signs. Signed numbers, where are they? Well, we're going to add signed numbers to whole number system, but we're going to define a new system. Some books represent integers by Z, some others use I. So if you open a math book and you see either of these two letters, it means that it represents signed numbers or integers. -2, -1, 0, 1, 2, and the rest of the positive numbers. Then, okay, what about fractions? We don't have any fraction here. We're going to create a new system, rationals, Q, and we're going to say, hey, since we cannot list all of the rational numbers, we're going to use a set notation. We're going to say that Q is the set of all fractions, A divided by B, such that A and B are integers. But the denominator cannot be 0, so you're going to put a comma and B is not 0. Very well. Then they came up with numbers like square root of 2, square root of 5, pi, Napier number, I don't know, -1 over pi, and numbers like this, which are not rational numbers. So they call them irrationals. Q, complement, or irrationals. They put a little c on top of Q and they call it irrational numbers. Okay. R is the union of rationals and irrationals. This is the union operation between two sets. So this is the union of two sets. So remember that we denote this guy by real line, and when we are graphing, plotting points, we have x-axis or y-axis representing r, negative infinity to positive infinity. So now remember that let's start talking about solving equations. I'm going to give you the reason why we are not stopping at R and we are introducing a new system, complex numbers. We call that. When I ask you to solve an equation like x squared plus 1 equal to 0, if you look at the graph of this quadratic expression, the graph of this quadratic expression behaves like this. At 0, it's going to be 1, and it's above x-axis. this graph, x squared plus 1, has no intersection with x-axis. So x squared plus 1 has no intersection with the x-axis. So what's the meaning of that? It means that it doesn't have any x-intercept. So it does not have any x-intercept. Well, what's the meaning of that? It means that if I solve this, I do not get any real solution. And I subtract 1 from both sides, or if I use quadratic equation, quadratic formula, it doesn't matter which method you're using. You get x squared equals to -1. And if you take the square root of both sides, you get square root of -1. And if you use a calculator, you get an error. This is an error. Why is that? Because square root of -1 is not a real number. Not a real number. Well, okay, that's not a real number. Should I leave it as it is? Of course not. We're the mathematicians. We are interested in taking these not real values and defining something new. We call it a complex number. So a complex number is defined as a plus I times b, such that I is equal to square root of -1. The square root of -1 has a representation which is denoted by I. So a complex number is a real value, plus I, which is square root of -1, times b, which is another real number. A is real, b is real, but I is square root of -1. So we started by defining natural numbers, then we moved to whole numbers, integers, rationals, irrationals, reals, and finally, complex numbers. So now that we introduced complex numbers, as we added, subtracted, multiplied, divide these numbers, we're going to learn how to add, how to subtract, how to multiply, how to divide complex numbers. Very good. So let me find my eraser. So now let's talk about operations between complex numbers. First of all, let a plus I b and c plus I d be two complex numbers. I'm going to write down the definition here and one example next to it, so you see what are we talking about. So suppose you have 2 plus I times 4 and 1 plus I times 3 be two complex numbers. So I'm giving you two complex numbers. We can add these two numbers. Okay. So I'm going to take A plus IB and add it to C plus ID. Okay. The operation in between is addition. So I'm going to use a different color, plus addition. Well, officially, it is equal to A plus C plus I, B plus D. Officially, this is how we define the addition or the sum between two complex numbers. Now, what's the addition between these two numbers? 2 plus I4 plus addition 1 plus I3. So what are you going to do? You're going to add these two constants, which is 3 plus 4 apples plus 3 apples is 7 apples. All right. So again, I times 7. 7 apples plus 4 apples plus 3 apples is 7 apples. Think about it this way. You're just adding two complex numbers together. So officially what you're doing, you're taking the constant parts, the real parts, and add them together, like this case. And then you're going to take the complex parts and add those together, I times B plus D, as we did here. Very good. Another example. Let's make it more interesting. Example A, example B. Now suppose you have, for example, 1 minus I and negative 2 plus 2I. Remember that here you have multiplication. You can write it as I times 3 or 3I. You can write it as I times 4 or 4I. 2I or I times 2. Suppose I want to add these two numbers together. It means that I have 1 minus I, copy down the first number, plus copy down the second number. Negative 2, so let's put it in parentheses, plus 2I. Okay, but we already know that plus minus is just a negative. 1 minus I minus 2 plus 2I. Okay, it's the same as before. Here I have the real part, 1 minus 2 from algebra is just negative 1. And I also have the complex parts, all right? I have negative I plus 2I. 2 minus 1 is 1. I get I back. Plus 1 I, or just negative 1 plus I. Very good. So let us make it more interesting. Suppose now I give you fractions involved. Why not? Fractions are important part of math. Suppose I have a half plus I, and I have 3/4 plus 2I. Okay, very good. My goal is to add these two numbers. So what are you going to do? You're going to add the real part, and then you're going to add the complex part, one by one. So here you have a half plus I plus 3/4 plus 2I. This guy is a half plus 3/4. You're going to add the real part. And then you're going to add the complex parts. So this is the real part. We need to simplify it. As a mathematician, we cannot leave this like this. And then plus I plus 2I. The complex part. So I plus 2I, which is written down here. Very well. So Now for the fractions. Let us go back to algebra. From algebra, we know that a half plus 3/4 can be written as, guys, they do not have the same denominator. They must have the same denominator so we can add them together. Well, 4 is going to be the denominator that the first fraction needs to have, but it is a half. I'm going to multiply the numerator and the denominator by 2, and I transform the first fraction into 2/4, and the second fraction stays the same. Now that they have the same denominator, you write one denominator and add the numerators, which is 5/4. So this side becomes 5/4 plus 1 apple plus 2 apples is 3 apples. So this is your final answer. Okay, now that we talked about addition, adding the real parts and adding the complex parts, now we're going to talk about subtraction. There we go. Let us write down subtraction. Suppose you have two complex numbers, like the very first complex number is 2 plus 3i, and the second complex number is 1 plus 5i. I have two complex numbers. We can subtract these two complex numbers, but we should be careful. We can subtract these numbers, and officially we write it this way: a plus ib, or bi, minus, guys, subtraction. You have to use parentheses for the second complex number, c plus id. Okay, officially, you have to distribute this negative sign into parentheses. Distribution. It becomes a plus ib minus c minus id. Well, now you have real part. It's going to be a minus c plus, and for the complex part, if you factor out I, you're going to have b minus d. This is the difference or subtraction between these two complex numbers in general form. Okay, what about these two? I have 2 plus 3i minus, guys, subtraction. Quickly write your second complex number into the parentheses. Here you have 1 plus 5i. Now your job is to distribute this negative sign into parentheses, am I right? Well, we get 2 plus 3i minus 1 minus 5i. Now we start adding the real parts, adding the complex part. 2 plus minus 1, or 2 minus 1, is just 1. 3i minus 5i is negative 2i. Subtraction, quickly use parentheses, because this subtraction affects the second number, both the real part and the complex part. Just note that if I switch these two numbers, my final answer is not going to be the same. It means that if I write this number first, 1 plus 5i, and do the subtraction, I'll use a different color, minus parentheses 2 plus 3i, this I is 1 plus 5i. Now you have to distribute this negative sign into the parentheses. Am I right? Well, the second number becomes -2 minus 3i. Now you have 1 minus 2, which is -1, and you have 5i minus 3i, which is positive 2i. These two numbers are different from each other. So the order is important. Which number comes first? The order is very important. If you change the order, we get two complete different complex numbers.